Welcome back to day 14 of the Topic Plus Revision series. Today's topic is trigonometry, and we're going to cover both right angle trigonometry and non-right angle trigonometry. So there's a lot to get through in this video. So as always, have your pack ready and let's get started. First 6 questions in today's video focus on right angle triangles, and then the second 6 are going to look at non-right angle triangles. So this first question here, we've got a right angle triangle. We know 2 of the sides and we need to find the third side. Now the side we're trying to find is across from the right angle, so this is our hypotenuse. And one thing we know about the hypotenuse is it's always the longest side, and that's really important when we're trying to figure these questions out. Now because again we have 2 sides and we're finding the third, we're going to use Pythagoras' theorem. So Pythagoras' theorem. Now you may have seen this as a squared plus b squared equals c squared, or c squared equals a squared plus b squared, or any variation of that. The way I like to do it is this. You can do it all pretty much in one go. We're going to do the square root of, then we're going to do the biggest side that we know, which in this case is x squared, then the smaller side that we know, which is 6 squared. Now all we need to decide is, with this x, is this going to be bigger or smaller? Now, as I said earlier on, the hypotenuse is always the biggest side, so that x is going to be the biggest side. So what we're going to do is we're going to add these two values together. So we can do this one without a calculator. So that's the square root of 64 plus 36. X equals the square root of 100, and the square root of 100 is 10. So in this case, x is 10. It's always good to figure out before you start whether x is going to be bigger or smaller, and then all we need to know is are we going to add or subtract those two values. If it's bigger, we add. If it's smaller, we subtract. So another right angle triangle here. We know 2 sides. We're trying to find the third side. So again, we know that this is Pythagoras' theorem. So we can do the same thing we did in the last one. X equals the square root of the bigger side, which is 11 squared, and then the smaller side, which is 5 squared. Now we just need to look at this x. Well, across from my right angle is my hypotenuse, and my hypotenuse is my longest side, so x must be smaller than 11. So all that means we're going to do is we're going to subtract this. Now we'll just put this into our calculator, save ourselves some time in this case. Now if we put that into our calculator, it gives you an answer of 4 root 6. Now that might be useful in some cases, but in this case we're asked to give it to 1 decimal place. So that's 9.797, etc. So when we round that, that's 9.8. So we would say that x equals 9.8. So this question here, we have another right angle triangle. We're asked to find a side, but we're not given 2 sides in this case, but we are given this angle here. And because we're given the angle, we know that this is usually going to be SOHCAHTOA. So particularly when we have right angle triangles and there's an angle involved, it'll usually be SOHCAHTOA. But just check, because if you have 2 sides and you need to find the third, we just go back and we use our Pythagoras theorem. So let's label our triangle. Across from our right angle is our hypotenuse. Across from our given angle is our opposite, and then our other side is our adjacent. So we're trying to find the opposite and use the adjacent. The hypotenuse is no use to us because it's not what we're trying to find, nor is it the value that we know. So therefore, because we're using the opposite and the adjacent, or O and A, we're going to use TOA. So if we sub that in, tan of 38 degrees is equal to the opposite x over the adjacent 9. Now we know from our solving equations video that to solve this, we just multiply across by our 9. And we get 9 times the tan of 38 gives us x. Putting that into our calculator, x equals 7.031, etc. And then rounding that, as it asks for, to 2 significant figures, that gives us 7.0 centimeters. Now, another one very similar to the last one here. We have a side, we're missing a side, and we have an angle. So again, we know this is going to be SOHCAHTOA. So let's label this again. So the hypotenuse is our x, the opposite is our 13, and our adjacent is the other side. Again, we're going to use the opposite and find the hypotenuse. Again, adjacent is no use to us, so we're going to use sine. Subbing that in, sine of 51 degrees is equal to the opposite over the hypotenuse. Again, from our solving equations video, and we've seen a few things like this now, when we've got this x on the bottom, the easiest thing to do is to swap this sine 51 with that x. So therefore we've got x is equal to 13 over sine 51. Putting that into our calculator, we get x equals 16.727. Looking back, rounding to 2 decimal places, x is equal to 16.73 centimeters. Now one more here, we've got a right angle triangle. We know two sides, but in this case, we're asked to find the angle instead. We're going to do this in exactly the same way we did before. The only difference is we have to use sine, cos, or tan inverse. Or on your calculator, you press shift sine, shift cos, or shift tan. It's that little thing that you'll probably have seen before, which is like the sine minus 1, as some people call it. We call that sine inverse. So, labeling our triangle again then. This is my hypotenuse. This is my opposite. This is my adjacent. Our opposite is no use to us, so checking with SOHCAHTOA. The one that uses adjacent hypotenuse is cos. So cos of x, that angle, is equal to the adjacent, which is 10.1, over the hypotenuse, which is 17.2. So then to get x on its own, this is where our cos inverse comes in. We use cos inverse of 10.1 over 17.2. X equals, we put that into our calculator, and we get an answer of 54.04. And then to two significant figures, x equals 54 degrees. Now our final right angle triangles question is this one. We've got two right angle triangles that are connected to each other. And the common thing, or the thing we'll normally see when we do these questions, is we find the common side first. So the first thing we're going to do is we're going to find that side that they share. So in this case, I'll call it y. We've already used x, so we'll call that one y. Now usually it's going to use the triangle that x is not in. So in this case, the top triangle. We can see we've got two sides. We're trying to find the third. Okay, so that's back to our Pythagoras. 12, remember, across my right angle, this is our hypotenuse. So we know that y is going to be smaller than 12. So therefore y is equal to the square root of 12 squared minus 7 squared, which if we put into our calculator, gives us an answer of the square root of 95. Now we're not going to work that out as a decimal because we can use that root 95 in the next part of the question. Looking at our bottom triangle then, our hypotenuse is x, our opposite is this side, and our adjacent is that value of y. So we're using SOHCAHTOA here, and we're using the hypotenuse and the adjacent. So we're using cos. So cos of our angle, which is 46 degrees, is equal to the adjacent, which we just worked out as the square root of 95, over the hypotenuse, which is x. And now we're back at that situation where our unknown is on the bottom. So we can just do our little swap here. And we get x is equal to the square root of 95 over cos of 46. Putting all that into our calculator then, you get 14.03. Giving your answer then to one decimal place, our answer is 14.0 centimeters. So this next set of questions is working with non-right angle triangles. So we can see there's no right angle in this one. And the question you always want to ask yourself, if you're familiar with this topic, you know the choice you have to make is between the sine rule and the cosine rule. The quick way to decide which one you're going to use is the question you have to ask is, do I have a pair? What I mean by that is, do I have an angle and the side opposite it where I know both of those values? In this case, the answer is yes. So I know I'm using the sine rule. Now I know that the sine rule is the one I'm applying. I also want to try and make a prediction about x. Now with x, I know that this x value is going to be bigger than 14. Now the reason I know that is because 97 is a bigger angle than 52, and the bigger side is always opposite the bigger angle. Therefore x has to be bigger than 14. If it's not, I'll have made a mistake. So subbing this into our sine rule. Now the way I like to use the sine rule is I like to put the unknown value in this top left hand position of the first fraction. So that's where my x goes. Underneath that I get my sine of 97. And then I fill in my other fraction, which is the side on top, 14, over sine 52. The reason I like that x on top is because now all I have to do is multiply across by this sine of 97. So x is equal to 14 over sine 52 multiplied by sine of 97. Now I've got most of the marks in this question without even using my calculator. It's only at this point now I'll pick my calculator up and I'll work it all out in one go, which gives me an answer of 17.633, which then, rounding to one decimal place like it asks, I get x equals 17.6 centimeters. So remember, if you have a pair, i.e. the angle and the side opposite it, you're using the sine rule. Otherwise, you're going to use the cosine rule. The second thing to remember is that if I've got a bigger angle, the side opposite is going to be bigger. If I've got a smaller angle, the side opposite is going to be smaller. Another non-right angle triangle in this question. So again, the first thing we ask ourselves is, do we have a pair? In this case, the answer is yes. So we know we're using the sine rule. Now the other thing I want to know is this x going to be bigger or smaller? Because 18 is smaller than 26, this is going to be a smaller angle. So it's smaller than 105 degrees. Now I don't need to write that, but it's useful to have in my head. I know my answer should be less than 105, and if it's more, clearly I've made a mistake. So setting up our fractions, fraction equals fraction. I want my unknown in this top position, and remember my angles are connected to sine. So that's sine of x over 18, and the other fraction is sine of 105 over 26. Again, I can just move that 18 across, so I get sine of x equals sine of 105 over 26 times 18. And then as I know, because I'm trying to find an angle, I'm going to use that sine inverse. Sine minus 1, or sine inverse of sine 105 over 26 times 18. And again, now I pick up my calculator and put it all in one go. And I get an answer of 41.968, etc. Giving that answer to three significant figures, I get x equals 42.0 degrees. Now in this question we've got another non-right angle triangle. And as always, the question we need to ask ourselves is, do we have a pair? In this case, the answer is no. So because it's no, we use the cosine rule instead of the sine rule. Now with the cosine rule, we have a squared equals b squared plus c squared minus 2bc cosine of a. The important thing about the cosine rule is the relationship between lowercase a, the side, and capital A, the angle. The reason we use the cosine rule is because we don't have a pair. The cosine rule allows us to find a pair. So in that case, we're making this pair of values. So this is little a, this is big A, and then b and c can be either way around. It doesn't make a difference. Now because we're finding a side, we can just use the standard cosine rule, which is given to you on your formula sheet, and you can sub all the values in. So that gives us x squared equals 15.3 squared plus 17.1 squared minus 2 times 15.3 times 17.1 times the cos of 121.5. Putting all of that into your calculator in one go, we get x squared is equal to 799.902599. Then all we need to do is find the square root of that answer. So the square root of 799.9 blah 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 gives us our answer. So x is equal to 282, which continues, and then as the question asks for one decimal place, that's 28.3 centimeters. Now in this case here, on your calculator, I would use the answer key or the ANS key. And what that allows you to do is just take this entire number and put it in there without having to type it all out again. So again, because we didn't have a pair, we use the cosine rule. So again, we've got another non-right angle triangle. Question we always ask, do we have a pair? Again, the answer is no, because we have none of the angles, so that means we're using the cosine rule. Now, it asks us to find the size of the biggest angle. Now, the biggest angle, remember what we said earlier, the bigger the side, the bigger the angle opposite it. So the biggest angle is the one opposite the 18, because 18 is our biggest side. So we're trying to find that one there. Now, I know our diagram doesn't look like that's the biggest angle, but that's fine. We just need to remember that the biggest side is opposite the biggest angle. And what that tells us for our cosine rule is that this is capital A, this is lowercase a, and then this is B and C, or the other way around for B and C. Now, with the cosine rule, we can use the one we did before, work it out, rearrange it, and solve for our angle. However, there is a rearrangement of the formula that you can memorize, which will make this a lot quicker for you, which is what I recommend you do. So the formula you need to memorize is that cos of A is equal to B squared plus C squared minus A squared over 2BC. Now if you memorize that, it makes this question so much easier, because now what we need to do is sub in our values. So we get cos of X is equal to 15 squared plus 14 squared minus 18 squared all over 2 times 15 times 14. And now we're trying to find X, and remember, when we're trying to find an angle, we always use the inverse. So X is equal to cos inverse of 15 squared plus 14 squared minus 18 squared all over 2 times 15 times 14. And as we've seen with a few of these, I've got most of the marks now and I've not even used my calculator. Final step now, I pick up my calculator and I put all of that in there, and that gives me 76.646. Checking back, it wants it to the nearest degree. So to the nearest degree, this is X equals 77 degrees to the nearest whole number. So as I said, with the cosine rule, if you're trying to find an angle for the cosine rule, what you want to do is memorize this formula. Okay, it'll make these questions so much easier rather than trying to use the formula you're given and then rearrange it. Now we've got another right angle triangle, but we need to carefully read this question. It asks us to calculate the area of the triangle. Now you may already be familiar with the area of a triangle, so a half base times height. However, with this case, we don't know the height, because remember the relationship between the base and height is that they're perpendicular to one another. So if you've got one like this, where you've got two sides and what we call the inclusive angle, okay, or the angle between them, we call this the inclusive angle, which is the angle between them, we can use this formula. And again, this formula is given on your formula sheet. So the area is equal to a half AB sine of C. C being the angle that we had, and A and B being the two sides. So this is capital C, this is A, this is B. If we substitute that in, our area is equal to a half times 12 times 17 times the sine of 60. Now we could do this without a calculator, because sine of 60 is a value we're supposed to know, but we'll just take it a little bit easier and we'll just use our calculator. So if we put all of that into our calculator, it gives us an answer of 88.334, etc. Now it doesn't tell us what to round this to, so if we just use sensible rounding, we can say, well, the area is equal to 88.3 centimeters squared. And this final question, it says two explorers leave their camp at the same time. The first one walks due west for 17 kilometers and the other walks 14 kilometers at a bearing of 135 degrees. How far are they now away from each other? And it asks us to give our answer to one decimal place. So with our bearings, we're talking about directions, and they do like to mix bearings and trigonometry together. So with our compass, we've got north, east, south, and west. But if we think of these as coordinates or as degrees or as bearings, this is 0, 0, 0 degrees. This is 0, 9, 0 degrees. This is 180 degrees. And this is 270 degrees. So if we draw a diagram for this, walking due west just means we're walking straight to the left. So it's a straight line to the left, and that's 17 kilometers. And using our compass diagram that we had there, it says a bearing of 135. Well, 135 is somewhere between 90 and 180, so it's down here somewhere. We don't have to be particularly accurate with that, it's just to give us a general idea of what our diagram will look like. So this one comes down here and goes to 14 kilometers. Now these are all based on a north line between the two of them. This is our north line. Now that's really important because this is due west, this is 90 degrees and this side is 135 degrees because that's what we had for our bearing. And now what we can do is we can work out the angle on the other side. And this angle is just going to be 135 plus 90, which is 225, and then 360 minus that 225 gives us 135. So the angle in here is 135 degrees. Now that's important because what it asks for is the distance between the two explorers now. And what we're going to look at when we ask about the distance, it's the straight line distance. So it's how far away are those 2 points. And now if you look, we've got two sides and an angle between it. So we've got a non-right angle triangle. If we draw it out here just to make it a little bit easier to read, we've got 17, 14 and 135. So now that we have that, we can check, do we have a pair? That's the first question. So the answer is no, so it's cosine. So because we're finding cosine of a side, we know this is the easier one. So we can just say, let's figure out our side is x. So x squared is equal to 17 squared plus 14 squared minus 2 times 17 times 14 times the cosine of 135. So therefore, putting all of that into our calculator, x squared is equal to 821.58. Again, using your answer key, we can find the square root of our answer. So 821.58, etc. And that tells us that x is equal to 28.66. Again, finally we check our answer to one decimal place gives us x equals 28.7. I'm getting our units correct here, kilometers. So the two explorers are 28.7 kilometers away from each other. So this is where they've mixed trigonometry with bearings, and it's worth drawing. It might even be 2 or 3 diagrams you have to draw, like I did here, to help you get to the answer. As always, thank you so much for watching, and I hope you found this video useful and it helps you to tackle those trickier questions in that pack. If you want to see all the videos from the series so far, you can click the playlist below, and we'll see you in the next video.